we have 3 fans, and each of those 3 fans have 3 settings. They could either be off, it could be on low, or it can be on high. So if we did a tree diagram for this one, we could say, let's start with our first fan. Our first fan has 3 options. It could be off, low, or high. Are you okay with those letters? Then, once we've set our first fan, for each of those options, our second fan has 3 branches. Woo. It could be on off, low, or high, off, low, or high, off, low, or high. And then our third fan woo. So for homework, I think I'm going to ask you to do the same example with 15 fans using a tree diagram. Good idea? So how many possibilities are there in total? There's going to be 27, right? And there are some very nice ones, like ooh, right? That is a nice fan setting. If I have 3 fans, I always like to set it this way. Very good. Anyways, we've got 27. And making the tree diagram gets a little bit cumbersome. Are we going to want to make a tree diagram every time? No. We're going to say to ourselves, hey, we have 3 decisions to make. I have to make a decision on how I'm going to set my first fan. I have to make a decision on how I'm going to set my second fan and how I'm going to set my third fan. How many choices do I have for my first fan? 3. How many choices for my second fan? 3. And for my third one, 3. Multiply those all together, and we get 27 a lot quicker. And if you were asked to do 15 fans and list or say how many possibilities, all of a sudden it doesn't become such a big problem. What this is called is something called the fundamental counting principle. What the fundamental counting principle says is that if you have a bunch of decisions to be made and you have a number of choices for each decision, the fundamental counting principle says basically make spaces for each decision that needs to be made. And once you've made spaces for each decision that needs to be made, put in the numbers of how many choices you have for each decision. So for example, I woke up this morning. I knew I was going to teach you guys, so I decided I probably have to get dressed. Well, I have decisions to make for socks, decisions to make for pants, decisions to make for shirts. So if I wanted to figure out, well, I should choose 2. I've got 4 spaces. So let's go shoes, socks, pants, and shirt. Well, I probably start with my socks. So if this decision is socks, and I say, well, I have 4 different colors of socks. I have more than 1 pair of each one, but 4 different distinct pairs of socks, colors that I could choose from. So I have 4 choices there. Then I go to my pants, and I've got, like, my whole closet is just pants. So I have 112 different unique pairs of pants that I decided not to wear my polka dot ones with the yellow stripes today. But let's say I have tons of pairs of pants. I've got 112 pairs of pants I could choose from. I only own 1 shirt. So I only have 1 choice there. It's got to be that one crisp white shirt that you notice that I wear every single day. And then finally, I've got 3 pairs of shoes. So now, if I wanted to figure out, now how many different outfits could I possibly wear if I switch socks and stuff, you know, and sometimes those outfits don't necessarily go together, like the bright yellow socks with the black pants maybe don't look the best, but if we multiply these all together right now, 4 times 112 is 448, times by 3 is 12, 13, 1300 something. You got a number there? 13 what? 1344. So I would have 1,344 different outfits I could wear if I'm not worried about how they go together. That's like, there's 200 teaching years, 200 teaching days in a school year. I have 6 years where you never see me wear the same thing, even though I'm wearing the same white shirt every single day. But the pants are different, the socks are, like, it's technically a different combination. And so we can count big things quickly. Like, it doesn't take long for us to figure out this number. If you tried to list them all, look at your closet, go, okay, white shirt, polka dot pants, yellow socks, 1, with green shoes. And then trying to list them all, that would take a very long time. But the fundamental counting principle lets us count these things quickly. So again, what do we do with the fundamental counting principle? We have to first realize how many decisions do we have to make. In our fan question, if we go back to it, in our fan question, we had 3 decisions, how we were going to set each of the fans. Then once you've got a space for each of your decisions, you put the number of choices for each decision in that space. Multiply it together and you will get the total number. Now this becomes very important for counting a lot of different things. And I think we get to one of those things in our next example. So I'll just stop this video. Oh, which questions you could do for this one? 3, 4, 6, 11, and 12.